friends and guests. Welcome to the 2014 annual Medhavadhanam. Since 2004, Srinivasa Ramanujan Mathematricks Club has been conducting classes every summer. Medhavadhanam was started in 2007. Srinivasa Ramanujan Mathematricks Club teaches children easy techniques that make normally strenuous, difficult, or time-taking problems into simple, easy math that can be answered in a minute, if not in seconds. In the Medhavadhanam, you, the audience, ask questions on a particular topic. Each participant will answer the question relating to the topic within a minute. None of the students uses a paper, pencil, or a calculator. Using these techniques not only can help you answer questions fast, but can extend your capacity to hold knowledge. Srinivasa is currently a software engineer. Although he has work to do, his passion and soul remains in sharing math techniques with the youth of today. He has effectively taught math to students while spontaneously doing Medhavadhanams for 7 years. He's running Sanghamitra.org, an online magazine including puzzles, jokes, and mind-boggling math questions. Please give a warm welcome to the founder, Srinivasa Ramanujan Mathematricks Club. Srinivasa.
Thank you very much. Yeah, before going to the program, just I want to tell you something about Sanghamitra and then Srinivasa Ramanujan Mathematics in brief. Actually, Sanghamitra is formed based on three different contexts. Like the base of Sanghamitra is one is caring, and then sharing, and then love. These three things actually make up a human life fulfilled. That's what I believe in. Because we might have lots of stuff, like either it may be knowledge or food or money, whatever. But if we share it with others, we get a lot of joy while doing it. So, and then actually that gives fulfillment for a human personality. That is one thing. And then sharing I told, and caring. Basically, we always think about ourselves, and we usually don't care about neighbors most of the time. I'm not telling any person especially, but everyone, everyone, including me sometimes. So caring is very important. Like if someone is having some trouble, or if the person is needing some help, we need to extend our hand to help them out. So that comes under caring, and then love, of course. It comes automatically. There are 4 values we need to follow. One is truthfulness, and then righteousness, non-violence, and then peaceful. Non-violence. If we follow these 3 techniques, basically peace and love automatically comes into our life. So next thing, Sanghamitra actually started in 2004. Basically, prior to that also we used to do some non-profit work back in India and in US also. But 2004 actually we officially thought having some organization. So we named it Sanghamitra. Basically, I think you all know the meaning of Sanghamitra. It's basically friend of society. So basically that's why I always call everyone like friend, dear friend. Friend is the relation which there is no age bounds we can think of. Even 2-year-old kid or 9 years old elder person, we can call them friend. That's the best relation we can have. So that's why actually Sanghamitra name specifies that. And then in 2005-06 actually I started telling mathematics, Vedic mathematics for middle school and high school kids. And 2007 we started Medhavadhanam for the first time, and it's really a wonderful technique, and the kids love it, and of course whoever attend the program, audience, everyone actually likes that. So basically what we are going to do today, they learned, each one of them learned all the topics, but each one participant is taking one topic, like finding cube roots, finding square root of a number, things like that. So those things actually, if you want to do manually, it takes at least 4 to 5 minutes, some of the problems. But they can tell orally without using calculator or paper pencil within a minute time. So that is the amazing part. You are going to watch that in 2 minutes. Coming to Srinivasa Ramanujan Math Club, that is actually Sanghamitra, both actually started parallelly. Sanghamitra basically does share knowledge, wealth, whatever to different communities, like actually donated some funds for blind schools, and then some schools actually where they need books and clothing and all that for the kids. So that sort of help actually it has been doing. And then Sanghamitra online magazine used to come till 2011 July, and after that actually due to time limitation, I couldn't do it, but actually it went for almost 7 years. Every 3 months we used to release one magazine. Those magazines are still available under the website www.sanghamitra.org. So this is an interesting question, but I want to skip it because we are already half an hour late. This one actually came in emails. I think some of you might have noticed it. Based on your phone number, you can tell the age of your age. I mean, you need not tell it out, but you can calculate and you can figure it out your age. But basically, if you think it's a simple algebra, nothing complicated. That's what I wanted to explain, but now due to time shortage, probably we'll skip to the next topic. Next page. Next. Okay. These are the questions. Basically, if any person new to mathematics is, if they get, if they think mathematics is complex or something, these kind of questions actually really gives good understanding as well as confidence in themselves. See, for example, how many 3-digit numbers can you frame in such a way that hundreds place is greater than tens place and tens place is greater than units place. So the problem looks very simple, and if you understand it, solving is very, very easy. So these questions basically, if anybody is interested, you can note down the question and then you can send me an email with the answer. And based on the age level, basically if it is the kid is say in 3rd grade, you can teach in different way. If the kid is in 7th grade, you can teach in a different way. So all the problems actually, whether it is algebra, geometry or arithmetic, you can teach all age levels as long as they understand language and the basic numerical addition, subtraction kind of things. We can teach any level of kid the same problem in different ways. I can tell some examples. Suppose if I ask to find sum of numbers from 1 to 9, usually if you add 1 plus 2 is 3, 3 plus 3, 6, 6 plus 4, 10, like that, it takes some time. But if they understand the concept, like 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10, and 5 is the middle number. So if you take that way, 4 tens and plus 5, 45 is the answer. So like that, kids, they need not do all the calculation, but if they know the techniques, they can solve some other complex problems also easy. So that is the motivation behind this Srinivasa Ramanujan Math Club and Sanghamitra. Okay, next slide. Yeah, probably you might have seen this cartoon. Otherwise, just go through it. It's a very interesting one. Especially in US, of course, we see that. Okay, basically, one mom asked this kid to go outside and play. Actually, he was playing, some computer game, and he went outside, but he was playing still the computer game, taking the mouse outside, rather than playing outside, in the open air. So, our mind actually thinks in the same way. If you keep doing the same things again and again, we get used to it. Similarly, Yeah, similarly, many people actually ask me like, why do we need to learn all these math techniques? We can use calculator and do it quickly. Yeah, that is easy and we can do it. But the problem is we are not using our mind to the extent we can use it. So if we keep on ignoring it, after some time probably we may not do even simple addition like 3 plus 8. We may think in a couple of times, or we may look for calculator, which is not good. So that's why, I mean, at least the basic mathematics we can use our mind to calculate. So that is ideal. Next. This text actually, how many of you can read that text? Okay, come on, can you read it out? Can you come here and read?
7 is the 7th letter of the alphabet, so like it goes
No.
Go there and look. Nikhil, come here.
Try to read one paragraph, that's enough.
The 7th letter in the alphabet.
Okay. Basically, when you start it, it's really a little tough. But if you just go through it, nowadays actually in Facebook and all, everyone is chatting like that. So for money, they type M1Y. But we don't know what it is. It's a code word. Instead of 1, we write ONE1. So AMONEY. It becomes money. But it's like code word M1Y, like that. So figuratively speaking, that is the heading of that. And then actually 7H15, if you read that way, it's really hard. But if you go through it, it's this message serves, right? Serves. Yeah, serves to program. I think it's not clear from here, so yeah, we can read that way. What? Yeah, there are lots of things like that. Many times actually, okay, if you go to the next slide. Yeah, so if someone can read that one. Yes, if you put little effort, math is easy. But there are two E's. E's is easy. But many people, they don't see it. Because mine knows actually, it skips some of the words like that. So, and similarly, sometimes it adds the words also. If you miss some word, it automatically adds it and do it. That is the power of brain. Okay, next. So, how many of you see side pose of the person? Okay. What about front? Yeah. If you see that actually the face is partially given, like front appearance, and sometimes some people can see only the side pose. So it depends on our mind attitude. Like if we use left brain more, we see one picture. If we use right brain more, we use the other picture. But if we balance it, it really gives good results. Next. Okay, coming to this, we need to remember Bharati Krishna Tirtha. He is the founder of Vedic mathematics, and then he gave lots of information about Vedic mathematics. Using Vedic mathematics, we can apply it in algebra, trigonometry, geometry, solid geometry, and many other areas. He wrote 16 volumes of books, and unfortunately we lost that treasure. And finally, before leaving body, he just gave us one volume. He compiled all the 16 formulas in one volume. That's what we are left with right now. Still, many people are researching on that, because he gave one sentence and that can be used in multiple ways. For example, Ekarikena Purvena, there is one formula in Vedic math. That means one more than the one before. That can be used in different contexts. One for division, like 1 by 19 or 1 by 29, that sort of divisions, we can apply that rule. Or sometimes some multiplications like 46 times 44 or 93 times 97, that kind of multiplications we can do using that technique. And there are many other applications for that. And similarly, there is another application called Nikhilam Navataha Charamam Dasataha. That is the formula. That is all from 9, last from 10. This is very easy one. Okay, let me show you some example here. Is this visible?
Yes.
Okay. Suppose if I ask to find subtract this. Basically, yeah, someone answer this.
2, 3, 4.
Yeah, 2, 3, 4, 2. 2, 3, 4, 2. We use that technique here. Otherwise, we need to borrow from, this is 0, 0 minus 8 you cannot do, so you need to borrow from here and there is nothing here, so again borrow. This is going to be very complex for a child to learn. But suppose if we do one thing, if we subtract 1 from this and subtract 1 from this, and then that's easy to subtract. You get 9, 9, 9, 9, and then 7, 6, 5, 7. This subtraction is easy. No borrowing that concept. So that is given in a formula called all from 9 and last from 10. So in this case, from 9 minus 7, 2. So the answer you get is 2, 3, 4, 2. Okay. 9 minus 7, 2. 9 minus 6, 3. 9 minus 5, 4. And then 10 minus 8, 2. Simply we can do that way. So this saves a lot of time and then reduces complexity. Okay, next slide. Yeah, there are some formulas. Actually, we quickly go through that and then we can start the program. Okay, Ekadiki Purina, the first formula I told, like 65 times 65. They can tell the answer, okay, without saying. Who is going to tell? 65 times 65. Okay, Arpita.
4225.
Yeah. Actually, she used that technique. And the answer is 4225. Similarly, if I ask what is 95 times 95, Aditya. 95 times 95. Okay, come on, Sarvani. 9025. So similarly 35 square. So that's very simple. Like first we write 25 I square and then 3 times the next number. 3 times 4 is 12. So you get 1225. Simple. So you can do mentally. Like 75 square, 5 square is 25 and 7 times 8, 56. So 5625 like that. Next topic. And similarly if you have 4.5 times or 4.5 square, sometimes it's very confusing. But 4.5 means you can say 4.5. 4.5 square means it's 45 square and you need to put a decimal at correct place. So you get 20.25 or 21 by 4 like that. So yeah, if it is decimal we need not worry, but that gives the basic concept. Next. Yeah, this is also using Ekadiki and Purvena. Just like as an example, 46 times 44. It is nothing but we need to multiply the unit places. You need to add the unit places to add up to 10. That is working out. And then rest of the number is same. Like 46 times 44. 4 plus 6 is 10 in the units place. And then rest of the number 4 and 4, that is same. So in that case we can apply the formula. 6 times 4 is 24. That is the units place product. And then 4 times next number 20. So you get 2024 like that. Okay, next. Yeah. These are also some examples. Okay, you can skip that. Okay, there is another question like this. This is also find a number which when divided by 2 gives a remainder 1. When divided by 3 gives remainder 2. Divided by 4 gives remainder 3. When you divide by 5 gives a remainder 4. When you divide by 6 gives a remainder 5. So what is that number? You can try and answer it if you know. Otherwise, if you send an email, I can respond back.
3 by 3.
You know the answer?
First one.
What one?
The first
No, only one number. Yeah, it's supposed to fulfill all the requirements there. So if you divide that number by 2, you get a remainder 1. When you divide that number by 3, you get remainder 2, like that. What? 41. Suppose if you divide by 3, you get a remainder 2, right? When you divide by 4, no, it doesn't work, right? So like that, I mean, you need to, if you divide by 5, you get remainder 1. Actually, supposed to get a remainder 4. So this is, I mean, if you know math in detail, or sometimes if you use different techniques, sometimes this one clicks very quickly. But otherwise, I mean, sometimes it looks hard, but it's very easy when you know the answer. Okay, next. Yeah, multiplication 11. This one, I think most of you know this, I guess. 32 times 11. The simple steps are like write 3 and 2 as it is, and then in the middle number you need to add the 2 numbers and write it. If it is a 2-digit number, you get 352. So next, 75 times 11. Here actually you get a carry, so you need to write 7 and 5. In the middle you get 12. So you write 2 and 1 carry. So 825 is the answer like that. Next, here actually if you have 3 digits, we need to write the last extreme digits, and for the middle numbers we need to add 2 digits at a time. Like see, 2 plus 3 is 5, that is actually 10th place, and then 4 plus 3 is 7, that is 100th place. So we get an answer like that. So for that, I mean, if you can remember 4 or 5 digits, we can do mentally without using any paper pencil. Okay, next. Yeah, this one already we covered, so we can go further. Next. Yeah, we have some examples how to do it. I think we can skip that. Okay, this question also is an algebra question. Like there are 3 expressions. We need to find a common factor for that. By seeing it, we can tell the common factor. The technique there is like when you add all the coefficients, if it becomes 0, then any idea? X minus 1 is a factor for that. So if alternative terms, if you take like x power 5 quotient, x cube quotient, and then x quotient, when you add them, and similarly even powered quotients, x power 4 quotient, x square quotient, and constant, when you add them, they are equal, then x plus 1 is a factor for that. So for those 3 equations, if you see, I think you'll get x minus 1 I think for that. You can try later. Anybody noting now? A question? I think we can skip. Next. Yeah, this is another technique which makes life very easy. If you see the numbers 9,993 times 9,996, that multiplication usually takes a longer duration, but using this technique it's very easy. Next. Here we take some base close to those 2 numbers. See, 993 and 996, both are close to 1000. So 1000 minus 993 is 7. So 993 is 7 short of 1000, and 996 is 4 short of 1000. So we write that way. That is the first step. Next step is we need to either subtract or add diagonally. See, 993 minus 4 or 996 minus 7. We get 989. That is first part of the answer. and then 7 4s are 28. But our base is 1000, so we need to fill 3 places. We get 0 to 8. 7 4s are 28, and we need to add a 0 there. So that is the answer. Simple addition and simple multiplication can do that. Okay, next. Yeah, I think we can skip this. For single digits also you can try. 8 7s are 56. But 8 is, if you take base 10, 8 is 2 short of 10 and 7 is 3 short of 10. We write that way. And then 8 minus 3 or 7 minus 2, which is equal to 5. That is first part. And second part is 2 3s are 6. When you write that, you get 56. That is the answer for base 10. And earlier we checked base 1000. And similarly it works for base 100, 10,000, anything like that. Next. Yeah, this is also similar thing, base 100. See, 89 minus 3 is 86, and then 11 3s are 33. So 8633. You can just visually you can see that and tell it. No need to use any calculator. Next. I think we can skip that. Yeah, this is also the same. You can skip that. Okay, if the base is 100 and the numbers are above base, we can use this technique. The same thing. Basically, instead of writing minus something, here write plus 23 and plus 3. That is the only difference. Now 123 plus 3 is 126, and then 23 times 3 69. So you get 12,669. That's the answer like that. Okay, we can skip that also. Yeah, these are squares. Actually, 101 square is 10201, and 102 square is also can be found that way. Skip this in. Okay, this is another orthotriac. This is basically now taught in Kuman and many other centers. So this is very common. I think many institutions they are actually telling this technique. So we can skip this also. Oh, sorry, this is actually we told about base 10 and base 100, base 1000 and all that. Similarly for base 500, base 200, base 300, for anything actually we can apply that formula with a little change compared to base 100 and 1000 and all that. See, for example, in this case, we are taking base 500 because 497 and 493, those two are close to 500. And now our original, theoretical base is 1000 and practical base is 500. So 497 is 3 short of 500 and 493 is 7 short of 500. So we write that, and now diagonally 497 minus 7 is 490, and because our theoretical base and practical base, if you consider, practical base is half of theoretical base. So 490 should be divided by 2, and then 7 3s are 21. Our theoretical base is 1000, so we need to fill 3 places. So we put 0 2 1. So the answer is 245,021. Next. I think we'll skip this. The same technique, yes, you can apply for 5,000 days. Yeah, this is actually vertical and crosswise. I think you can skip this. This actually saves time, like instead of using a 3-step method or 4-step method, we can do it in single step. That's the advantage. So actually I thought of covering all these, but because we started late, so I just want to skip. Okay, next. These are actually, the extension to the base method. Like for example, for 76 times 74, we use Ekadiki and Pujana. The same technique we can use for the other numbers, like 755 times 745. There actually 55 plus 45 makes adds up to 100, and then the rest of the number is same. So we need to change that formula a little bit to get the answer for that. And similarly, we can extend that in a different way, like 67 times 47. Here units place are the same, and tens place adds up to 10. So this is a little different from the previous one. So here we need to answer it with a slight modification. Okay, next. Okay, Vedic math is easy because it works with the mind. Many times, if I ask like 297 plus 6, how much? You can tell 303, because what you do is from 6 you subtract 3 and add to 297 to make it 300, and then the rest remaining 3 we add it. So 303 we get. Like that, mind knows how to calculate certain things, but if we just ignore that and we use calculator, sometimes we may forget it. But mind knows how to do it. So that's why it's very easy when you follow Vedic math. And then it's having very nice formulas in different areas. So one particular solution can be found in different ways. For example, if someone asks 67 times 67, usually if you multiply, we do in 3 steps, and that is the only method we know. But using Vedic math, we can use multiple ways, like using base method, or we can use vertical and crosswise, or we can use a different method. So that makes life easy, and we need to choose the right method at the appropriate time. Next. Yeah, I think we can just skip those pictures. These are previous math club photos, and different locations we give presentations and all that. Okay. Okay, now we'll start Medhavadhanam topics. I think most of you are having the questions, what are the questions you can ask, and what you need to find out before asking a question and all that. The trifold, that flyer is having all the information, and I am going to explain the same things quickly so that you will have an idea what exactly you need to ask and who is going to answer what. Okay, next. The first topic, okay. These are the instructions basically, like the highlights of the program. No calculators are used in the program here. Actually, the participants, they are not going to use calculators. No paper pencils. An increased speed in solving problems. That you can see anyway. Next. This is basically how many of you know Divisible? There is a program called Medhavadhanam. Back in India, they do it, and they do most of the topics whatever we are doing here. But they actually do another thing to that thing. Like suppose if they are answering cube roots, fifth roots, and then square of a number, something like that. And after that, at the end of the program, what they do is like who asked the question, and what is the question, what is the answer. They remember everything and tell at the end. That is the complex part. That is called dharana. We are not doing it because with the 8 weeks time, it's really hard to practice for that. And even I am also practicing that for some time. So it's really hard to do it here. So we are doing only answering the topics. That's all. But in Medhavadhanam, they do additional thing, like they tell all the questions and answers at the end, like a summary. That is really hardest part. Okay, probably down the line we might also do that, but I can't guarantee when and which year. Okay, next slide. Okay, the first topic is square root. You doing square root? Yeah. Can you stand up? Yeah, she is doing square root of a number. Basically, what you need to do is you need to choose any number from 1 to 100, any number, and then find the square of the number. If you have calculator, or you can use manually, using paper pencil, you can find square of the number. If you tell the square of the number, she is going to tell the number you have chosen. So that is the first topic. Okay, let's do two questions on this, so that everyone understands what exactly, how exactly she is doing it. Later we are going to have a continuous session. Okay.
7056.
7056. You want me to write it here? Come here. Let me write it. 7056. Is that correct? Yes. Okay, another question. One more question and then skip to next topic.
4356.
4356. Okay, let's skip to the next topic. Afterwards, actually, once we complete all the topics, you can ask any topic, any question, but make sure you cover every student so that they will not feel bad. Okay? Yeah. Cube root. Next topic is cube root. Arpita is doing it. Yes. Yeah, you can come here. This one basically you need to choose any number from 1 to 100. Find cube of the number. Basically, suppose if you take 2 cube, 2 times 2 times 2. If you take 7 cube, 7 times 7 times 7, like that. So when you find the cube of the number, you need to tell the number, and she is going to tell the number you have chosen.
1 7 5 7 6. Good.
Another question.
39304.
I think it's not a valid one. It's not perfect.
Okay, let's go to the next question.
Okay, next question.
Next question.
474 552.
No, not a valid number.
Why not?
That is not in this range, I think.
Oh, what's the range?
Between 1 and 99, right?
Yeah.
Yeah.
You are finding cube only, right?
Yeah.
Oh,
Oh, sorry. 474. I think probably. Yeah. Right? 474 is right?
That's right. That's right.
yeah.
78.
Basically, if you give random numbers, it may not work. For example, if you give 3741, it's not a perfect cube. So you need to give perfect cube to solve it. Later, actually, they can figure it out. After some time, they can figure it out. Like if you give any number 4752, they know it's close to 13 or close to 14, something like that. They can tell.
Excuse me. Anybody want to use? You can use this calculator to ask the question. You can pass on to others.
Okay, next topic is framing full digit number divisible by 13. Gauri. So this one goes like this. You give 3-digit number, any 3-digit number, and she is going to tell another 3 digits. and again you give 3 digits, and she is going to tell another 3 digits. So you have a 12-digit number now. When you divide that by 13, you get a remainder 0 all the time. Okay. I'm checking.
453?
So 4, 5, 6 into 1 sheet.
Yeah. Oh. 500.